Welcome learners to my normal online lessons, chemistry, Mr. Simiyu Zablon. Today, let us look at the basic terms used in alkaline earth metals. The other lesson we looked at the alkaline earth metals with their physical characteristics. We looked at also the atomic radii, how we move across down the group. So let's now, we also highlighted the alkaline earth metals, beryllium, magnesium, and calcium. So today let's look at what will happen when alkaline earth metals, number one, exposed to air. Automatically when they exposed to air, in air we say that air is a mixture of gases. If air is a mixture of gases, we have active part of air, oxygen, and we have nitrogen. So when alkaline earth metals are exposed to air, they will react with oxygen. When they react with air or oxygen and nitrogen, for example, magnesium reacting with oxygen, when it reacts with oxygen, it forms an oxide. That oxide, it coats the metal. We have that these metals are shiny. We will find that they lose that shiny property. So they become tough and blunt. So they rust. We have said that they have a coat. That oxide coat, we say that metallic luster. So metallic luster, it's formed when a metal or alkaline earth metals get oxidized. When they get oxidized, for example, we have magnesium plus oxygen, it forms magnesium oxide. So when they get exposed, that is a solid also, it's a gas. When they get exposed, this metal gets oxygen. So they form an oxide. That oxide formed, or it covers the metal when they exposed to air. It's called metallic luster or metallic luster. Here, when magnesium reacts with oxygen, it forms magnesium oxide. So let's balance the equation. Let's balance the equation first. Let's say we have oxygen, these two, we have oxygen 1, so we make magnesium oxide to be 2, and then if you make magnesium to be 2, in this side of product side, it is 2 magnesium, so we also put here 2 to balance the moles of magnesium. So when you write an equation very well, make sure that it has a balance, and then it has the chemical symbols. Let's look at malleability. Yes. We have said that 2 magnesium state simple, that's magnesium solid, and then plus oxygen, that's state symbol, so oxygen gas, and then you get 2 moles of magnesium oxide, that's also a solid, a state symbol. Let's move out to a certain or another property of these alkaline earth metals, malleability. Malleability is the ability of metal to be drawn into sheets or to be hammered into sheets. Ability of the metals to be hammered into sheets. So you will be told to explain what is malleability. Ability of a metal to be hammered into sheets. So malleability of the metal to be hammered into sheet, you will find that it depends with the forces of attraction. Those metals that are very, very soft, like for example magnesium, it's very, very soft. It can be hammered into sheets. You will find that you might have magnesium ribbon, ion sheets made up of magnesium. So those ion sheets have been hammered. It was once a metal, and then it being hammered to form sheets. So hammered into sheets, called it malleability, ability of the metal to be hammered into sheets. Not all metals are being hammered into sheets because they have different physical properties concerning with the forces of attraction holding the molecules together. You will find that when magnesium is being hammered, the particles comes together to join together. But you'll find that when we to be hammered into sheet. Why? Because of the particles, arrangement of the particles in calcium. We have said that calcium, it has a large atomic radius. So the arrangement of particles is far away from each other, those atomic particles. Let's move out to another term called ductility. Ductility is one of the terms being used in alkaline earth metals. We have said that ductile or ductility, ability of this metal to be drawn into wires. We have said that magnesium is one of the metal in alkaline earth metals being drawn into wires. It can be drawn into wires. Why? Because we have said that the arrangement of the particles of that element. So you will be told to define what is ductility. Ductility is the ability of the metal to be drawn into wires. To be drawn into wires is the ability of the metal to be drawn into wires. That is ductility. And we have said that it's only magnesium being drawn into wires. Let's move to another term, brittle. This brittle is one of the terms also has been used in alkaline earth metals. Resistance of the metal not to break. Resistance, it resists to break. So as it resists to break, it just breaks immediately. So we find that it's only calcium that it's brittle. It's only calcium that is brittle. We also say that due to arrangement of those particles, they resist resistance to breakage. Resistant to breakage. So they resist to break, which shows that metal is brittle. So these are the terms you need to be able, and you need to be able to learn about them and revise about them. Metallic luster, we have said that when these metals are exposed to air, they get oxidized. They form a layer, oxide. So that oxide in calcium, magnesium needs to be polished before it reacts, because that oxide will hinder reaction. We also said that malleability is the ability of those metals to be hammered into sheets. And we have said that majorly it is what? Magnesium. This is magnesium. Magnesium is only metal being hammered into sheets. And we have said that its application, it can form or it can manufacture iron sheets. We have also said that its ductility is the ability of the metal to be drawn into wires, and it's only magnesium. It can form wires. Brittle, resistant to breakage, that is only calcium, and due to arrangement of the particles. So let's look at also the melting point and boiling point. Melting point and melting and boiling point. Melting and boiling point of these alkaline earth metals. Alkaline earth metals. Melting point and boiling point of alkaline earth metals. That is resistance of these metals. Number one, to lose that air when you are heating. How energy used to break those metals. Energy. We have said that in our previous lesson, we said that the energy holding these particles or the elements depends on the atomic size. As the atomic size increases, you will find that it weakens the forces of attraction. Forces of attraction. It weakens. Forces of attraction weakens. Why? It weakens because of the atomic size. So you'll find that in beryllium has smaller atomic size. Smaller atomic size increases the forces of attraction. As it increases the force of attraction, you'll find that for us to break those molecules, we use a lot of energy. So it raises the melting point and the boiling point of that beryllium. Let's look also at calcium. Calcium has larger atomic size. As it has large atomic size, it weakens the forces of attraction. weakens the force of attraction. So we can say that down the group in period 2, melting point and boiling point decreases down the group. Decreases down the group. Why? Because we may find that beryllium has 570 kilojoule. 570 kilojoule. There is the energy required to melt that metal. And then we have calcium. Calcium, we find that it has 207 kilojoule per mole, kilojoule energy. So we find that the energy reduces down the group. Why? Due to increase in atomic size. As the atomic size increases, it weakens the forces of attraction. Why beryllium has the higher melting point and boiling point? This is because the atomic size is what? Atomic size is small. Small atomic size, forces of attraction do what? Increases. So we can say that, we can now summarize and say that the melting point and boiling point decreases
with increase
down the group. Why? Due to the increase in atomic size. Due to increase in atomic size, that weakens the forces of attraction. So you will be asked a question to differentiate or to compare the melting point and boiling point of beryllium and calcium. Compare. So we say that in comparison, you give out the comparison first. For example, beryllium has higher melting point and boiling point than calcium. Or somebody else can say calcium has low melting point and boiling point than beryllium. When you give out the reason, compare and give out the reason. Beryllium has smaller melting point, low melting point and boiling point than calcium. Why? This is because beryllium has smaller atomic size that strengthens the forces of attraction. Or somebody else can say calcium has low melting point and boiling point than beryllium. Reason? Because calcium has larger atomic radius that weakens the forces of attraction. So continue following and welcome to our lesson again. Thank you.